Hi, I'm Brian from mathmojo.com/Kenken, and I'd like to show you the rules and a simple way to solve a simple 4x4 Kenken. The rules are very simple. In every row and in every column, the columns go up and down, the rows go horizontal. You have to have the numbers from 1 to 4 if it's a 4x4 cell Kenken. If it was a 6x6 cell, you'd have the numbers 1 to 6, etc. So each of these cells have to have the digit from 1 to 4 in it, and you cannot repeat. In other words, you can't have a 1 here and a 1 here. So the numbers 1 to 4 here, 1 to 4 here, 1 to 4 here. If you know Sudoku, in Sudoku you also have to have the numbers 1 to 4 in here with no repeats, but that's not the case with Kenken. Don't let that confuse you, and I'm sorry if I just did. Okay, those are the rules. The other rule is in every one of these cages, a cage is where it's in dark, you have to have the numbers come out to whatever this number is in the corner using whatever operation it is here. In other words, the two digits that will end up in here will give you an equation. Something minus something must equal 2. And in this cage, something times something times something must equal 6. In this cage, something plus something equals the 7. Those are the rules. Our job is to find what those somethings are. Well, let's make it real easy. When you have a cell like this, I like to represent, it's very easy to represent all the numbers like this. 1, 2, 3, 4. Because it's a 4x4 cell and you can see these very easily. And then what I like to do is say to myself, what numbers can't they be? Well, we only have the numbers 1 to 4. Is there anything that you can add 1 to that will give you 7? That's 4 or less. No, there isn't. Is there anything that you can add to 2 which will give you a 7? Well, at 5, but it's too high, so you can't use a 2 in here because you can't use a 5. These are the only digits left. So the only possible digits here would be the 3 and the 4, and that's pretty simple. I think you can follow that. If not, just play it back. A lot of you may already know this, and don't get mad at me if I'm showing you very easy stuff, but it's really not easy if you're beginning, right? These clues can be valuable. That means that there's possibly a 3 here, could be a 3 here. We don't know which ones you can, we know which ones you can add, but we don't know the order. But we do know there can be no 4s here, or no 3s here, because if this is a 3, this must be a 4. If this is a 4, this must be a 3. That's the only possibilities. And by knowing your only possibilities in one area, you know what the only other possibilities are here. This can only possibly be a 1 or a 2. We'll be able to find out which one pretty soon, but we just pencil them in lightly now. It can only be a 1 or a 2. What else do we know? Well, here's a gimme. Here's a 4. There are no operations. That's a gimme. That means they're giving it to you. It's just a 4. That's pretty easy there so far, too. Let's see what else we can get pretty easily. In this 3 cage, you're going to have to do subtraction. Well, what can you subtract to get 3? Can you subtract a 2 from any numbers to get a 3? No. You can't subtract the 2 from the 1, you'd get a negative number. You can't subtract the 2 from the 3, you'd get a 1. We don't want a 1, we want a 3. And we can't subtract 2 from 4. So you really can't use any numbers here if you think about it, except a 4 or a 1. 4 minus 1 is the only possible combination. If you know this is the only possible combination, if there's a 1 here, there must be a 4 here. And if there's a 4 here, there must be a 1 here. And that means there cannot possibly be a 4 over here because you can't have two 4s in the same row. So now we know for sure this must be a 3. We've already solved it. Now if this is a 3, this must be a 4. Now I'm going to erase these. Once I know what they are for sure, I erase it and then write it in big or in pen. So we know what goes over there. Well, that's pretty cool so far because that gives us a bunch of things. We also know here, when we look at this gimme, that this cannot possibly be a 4. And since that can't be a 4, the only combination that'll work here is the 4 here and the 1 there. Now I'll erase them and write them big again. We know by process of elimination there's only one possibility that can go here. It's got to be the 2. And if the 2 goes here, something minus 2, or 2 minus something, a 2 has to be involved in a minus equation, in a subtraction equation, to give us this 1. What could it be? 2 minus 1 would work, and 3 minus 2 would work. There's nothing else that can possibly go in there. Let's see what we've got going on in here. In this division, what could possibly give us division problems that will end up with 2? There could be a 1 here and a 2 here. In other words, 2 divided by 1, or a 2 here and a 1 here. But we know that's not going to be a possibility because of this 1 over here. We'll erase that in a second. Let's keep going. Can a 3 be involved in a division equation that ends up with 2? Not with the numbers we have working. And we know we can't use a 4 here to have 4 divided by 2. So the only possibility now, since we know that there can be no 1 over here, is this. Now I'll erase these and rewrite them large. The 1 here and the 2 here. 1 here, 2 here. Well, then this must be a 3. That's good so far. That makes things pretty easy. And in a 2 division here, we know we can't have the numbers 1 or 4. So there's a must be a 2 over here. And since we know that, we know this must be a 3 over here. Well, what can we subtract? What can we use in a subtraction problem to give us a 3 here? This can't be a 4 because we know that. It can't be a 2 because 3 minus 2 would give us 1. So it can only be a 1. 3 minus 1 gives us this 2. Well, if that's the case, and it is, this cannot possibly be a 1 over here, and this cannot possibly be a 1 over here. So we know this is going to be a 3. Let's write it in big. If that's a 3, that's definitely a 4 here. That's true. 4 divided by 2 will give us 2. And if this is a 2, let's start erasing stuff. We know this is going to be a 2. And we know this must be a 1. Let's erase it and write it big. And we've solved our first Kenken together. You can find out more about Kenken at mathmojo.com/Kenken. I hope you enjoyed this little lesson, and we'll have more over at the Math Mojo Kenken site.